All right, short lesson today. We're continuing our talks about polynomial division. There is one more way to divide polynomials if the divisor meets a very specific requirement. If my divisor, and this goes for your long division too, unfortunately because we're using the box method and that's what's on Delta Math, you can't just put in the answer. But if your divisor is a linear term with a coefficient of 1, you can use this method. It is an algorithm, meaning it is a quick way for you to divide polynomials. Are we ready? I'm going to do one and kind of walk through the process. We're going to do one together, and then I want you to try one on your own. Okay, here we go. You are asked to use synthetic division to find the result of 3x to the 4 plus 3x cubed minus 5x squared plus 8x minus 9. Now, if we were doing the box method, we'd have to draw boxes. We'd have to do this whole thing. With synthetic division, if my divisor, it has a coefficient of, if it's a linear term with a coefficient of 1, then we can do this very quickly. Here's what we need to do. We need to draw this bar here. It's kind of like the division bar, but inverted, right? Reflected. And here's what we want. On the outside, we're going to do the opposite of -1, which would be what? +1, right? So 1 is what I'm going to write over here. And then what you need is you need the coefficient of each one of the terms in your dividend, right? In the divisor, in the polynomial that we're dividing, okay? So I have 3, -5, 8, and -9. Are we okay so far? Haven't done any math yet. Just setting everything up. So here's what we're going to do. The first term, no matter what it is, even if it's x to the 3 or x to the 2, doesn't matter. You're going to drop it down. We're not going to do anything to it. You're going to bring it down here, underneath that bar. Are we okay? Here's what we're going to do now. We're going to multiply this 1 times that number underneath. What does that give me? 3. So then I'm going to write it over here. Then what we're going to do is we're going to add everything underneath that the second 3, right? The 3 and 3. What does that give me? 3 and 3 gives me 6. And then we go again. So remember, we multiplied these and then we went this way. Same thing here. What are we going to do? We're going to multiply this 1 times this 6. That gives me 6. -5 and 6 gives me 1. 1 times 1 gives me, and then 8 plus 1 gives me 9. And then 1 times 9 gives me 9. And -9 plus 9 gives me 0. Everybody, my last term will always be my remainder. So, in order for us to write this correctly, we need to understand that when we are dividing polynomials, our answer will always be 1 less than the leading term in our dividend, right? Meaning we need 1 less than x to the 4 power, which would be what? X to the 3 power, right? So here we go. My answer is 3x to the 3 plus 6x squared plus x plus 9. Let's prove to see if this is even true. Here we go. So what are we doing? What operations are we doing? We are doing 3x to... Actually, let me do the fraction bar first. 3x to the 4, and remember you have access to this in your own exam, so I'd use it, plus 3x to the 3 power minus 5x squared plus 8x minus 9, all divided by x minus 1. So we get some polynomial that looks like this, right? Well, let's see if the answer that we provided matches that. We have 3x to the 3 power plus 6x squared plus x plus 9. Looks like we did it right. Again, this is an algorithm that works only if I'm dividing by a linear term and the coefficient of that linear term is 1. This will quickly allow you to divide. Boom, you're out. Okay, so now let's try one together. I'm going to write out my coefficients first. 2, negative 8, negative 3, 28, and negative 3. Yes? Now I want the inverse of negative 3, right? The minus 3, which would be what? Positive 3. Remember, the first term, we need to drop it down, right? So that's 2. 3 times 2 is 6. Negative 8 plus 6 gives me negative 2. 3 times negative 2 gives me negative 6. Negative 3 and negative 6 give me negative 9. Okay. 3 times negative 7 gives me negative 27. Sorry, 3 times negative 9 gives me negative 27. Sorry, already jumping ahead. 28 and negative 27 give me 1. And then 3 times 1 gives me 3. Negative 3 and 3 gives me 0. And that's my remainder. For level 1, everybody, you need to anticipate getting a remainder of 0. That is there for you to just get your feet wet and understand how to use synthetic division. Okay? So how do I write this? Well, let's look at our first term here. We started off with x to the 4 power, right? So our new answer, our result for this will start with what term? X to the 3 power, right? So here we go. 2, and everybody, these are the coefficients of each one of the remaining terms, right? That's what my answer is. Those are all the coefficients. So this is 2x to the 3 minus 2x squared minus 9x plus 1. Jen?
I don't get how there's no 4 or 4 squared or cubed, I guess. Like how it just goes straight into the power of 3.
Let's remind ourselves what we did last class, right? Let's look. What happens when we divided? What was my answer up here? 2x squared, right? What was my dividend here? 2x to the 3 power. Every time we are dividing polynomials, what do we do with the exponents? Sorry. No, that is when we multiply them. What happens when we multiply, we add them. When we divide them, what do you think we do? Subtract them. What is 3 minus 1? Hence my answer here. So when we divide polynomials, remember that we are subtracting the power, right? In this case, since my divisor is x to the 1 power, this is 2x to the 4 power. My result should be x to the 3 power. So it could change depending on your polynomial that we're dividing. But yes, it is always one less than what we start off with. Does that answer your question? Fantastic. Can I answer any other questions? Phenomenal. I want you to try, not this one. This one was a bad problem. Let's try this one and see what you think. 4x to the 3 plus 13x squared plus 6x plus 9 divided by x plus 3. I'm going to give you 90 seconds. These should be in your Delta Math assignment. Well, we'll talk about it afterwards. I'll give you 90 seconds to do it. Go. negative 12, 1, negative 3, 3, negative 9, 0. I end up with 4x squared plus x plus 3. Yes? We feel okay, everybody? Ask questions. If you're not understanding what's going on, ask questions. And remember, you're always welcome to ask questions either here, you can email me, or you can come to tutoring for a quick question. Aisha, what's up?
So like, we just always, why do we have to do the inverse? Like,
Here?
yes.
I won't go too far. Ask yourself, what times x gives me 4x cubed? 4x squared, right? And then what happens is that we subtract, right? So we subtract 4x cubed minus 12x squared. Notice how it's following this particular pattern, right? The reason is when we divide polynomials the long way, this ends up turning into the opposite of adding 3 when we're doing division. So we subtract, right? So because we're subtracting this times this in here. So that's why all we do is we just switch the 3. We just switch the sign. This will help us automatically just bypass this. Instead of doing it the long way like this, we are just bypassing it and doing it this way. Again, this is just an algorithm that works. It allows us to do it if our divisor meets those conditions, right? Does that answer your question? I know it feels a little empty, but this algorithm works. It works. Questions, anybody? All right, let's move on to level 2. We are now anticipating remainders, and that is okay. We are going to follow the same process as the remainders on Monday. What do we need to do with the remainder? The remainder... Remind me again what we did with the remainders. It was our remainder over the divisor, right? Same process here, okay? Let's do it. And just because it's level 2 doesn't mean that all of them will have a remainder, right? So, here we go. Let's do it together. Negative 2 goes here. 1, 8, 11, negative 11, and negative 18. Drop this one down. Negative 2 times 1 is negative 2. 8 and negative 2 gives me 6. Negative 2 and 6 gives me negative 12. 11 and negative 12 gives me negative 1. Negative 2 and negative 1 gives me positive 2. Negative 11 and 2 gives me negative 9. And negative 2 times negative 9 will give me positive 18. My remainder is 0. So what's my answer? X cubed plus 6x squared minus x minus 9. Charlie. I did, yes, and we will do it again. Whenever we divide exponents, what do we do with the exponents? We subtract them, right? For example, x to the 4 divided by x to the 1 power, what does that give me? X to the 3, right? Because we are dividing exponents. That's exactly what we're doing here, right? We're dividing this x with x to the 4. My result should be 1 less than the one less than the highest term. Does that answer your question? Fantastic. Can I answer any other questions? Beautiful. Try this one on your own. X to the 4 plus 8x cubed minus 16x squared plus 14x minus 1 divided by x minus 1. I'm going to give you now 60 seconds. You should be able to do this a bit faster now. 1 goes out here. 1, 8, negative 16, 14, and negative 1. Drop this. 1 times 1 is 1. This is 9. 1 times 9 is 9. This is negative 7. 1 and negative 7 gives me negative 7. This is positive 7. 1 and 7 gives me 7. This turns into positive 6. Your last term here, everybody, will always be your remainder when using synthetic division. So I have a remainder of 6. Confirmation for this? Yes? Yes? Okay, good. I just want to make sure that I'm doing it right as well. Because if we got different answers, then we can check it. So what does this mean? My answer is x cubed plus 9x squared minus 7x plus 7 plus 6 divided by x minus 1. And then I box it in because this is my final answer. Chess, everybody? Are we okay? Yes, can I answer any questions? I'm more than happy to answer questions, y'all. First period had a bunch of great questions. One more, try it yourselves. Give you 60 seconds. Notice that synthetic division doesn't really require much out of you other than just simple addition and multiplication. Yes? Go. Yes? How do we feel with synthetic division? Seems like a very quiet class. I'm going to try something. Someone talk to me. Why did I do that? Very good. So what term are we missing here? My quadratic term, right? My x squareds. In order for synthetic division to be done correctly, you have to have all of the terms in descending order. So even if you're missing either a linear term, quadratic, cubic term, it doesn't matter. You have to include a placeholder of however many terms you're missing, right? So I'm missing an x squared. I have 0 x squareds in this polynomial. So I need it in order for me to be able to do synthetic division correctly. That's the difference between level 2 and level 3. There may be some missing terms that you have to look out for. So here we go. 4, 4, 4, 4. Feel like Jeff Davis here. 4, 1, 1, 2. So I end up with 4x squared plus 4x plus 1 plus 2 divided by x minus 1.
Wait, isn't that 1 supposed to be?
Oh, yes, you're right. See, I make mistakes. Yes, everybody? How do we feel? Good? Okay. Try the next one on your own then. See what you think. 60 seconds? Okay, 66, sure. Sorry, messed up. Yes? Cool. Do y'all want one more? Actually, let's do this example just to make sure that you get a hang of missing terms. Last example that we're doing together, then the rest of the time will be yours for you to work on your Delta Math assignment. I'll give you 60 seconds. Okay, 66 again, sure.
So it's funny when you did it, but not when I did it. Yes? Yes, confirmation? Or like? I just wanted to know if the remainder is negative, would you put -6 or would you put -6 over
Just to be on the same, I mean, either one works. Personally, if I'm adding a fraction, I like to add the fraction and then whatever it is, whether it's positive or negative. Right? That's just my own personal preference. It still works. It's still mathematically correct. But yes, if it would have been like -6, you could have just said minus that. But again, for personal preferences, whenever I add fractions, even if the fraction is negative, I like to just keep it plus the negative fraction. Does that answer your question?
Yes.
Fantastic. Can I answer any other questions? All right, everybody. That's all I got for you. This is the last lesson of the unit. Friday is your review, official review day. And then Monday is your exam.
Are you gonna post the reading?
Yeah. Like the delta math? Or, yeah. That's exactly what I'm going to do.